Today, I'm talking about pressure plates, also known as clutch covers. All pressure plates are application specific, and yet they all have the same basic operational concepts with a few variations. The purpose of the clutch cover is to apply or release clamping force to the clutch disc. This will engage and disengage the transmission from the flywheel and engine power. The pressure ring is a flat machined surface that contacts the clutch disc. The clamping spring or springs are either a diaphragm or coil spring design. The retraction clip, stabilizer struts, and pivot pins and ring are all used on diaphragm spring clutch designs. The stabilizer strut stabilizes the pressure ring and the retraction clip connects the spring to the pressure ring. Pressing down on the center of the diaphragm spring causes it to pivot on the pivot pins and pivot ring. This causes the outer edges to rise. This pulls on the reaction clip, which in turn pulls on the pressure ring and releases the clutch. Releasing the pressure returns the pressure ring to its original position. The flat piece of spring steel is bowed or beveled. This beveling changes the flat spring steel into a diaphragm-shaped spring. For most automotive applications, it will often require well over 1,000 pounds of force to compress the spring. The greatest tension is when the spring becomes flat during compression. If the diaphragm spring is depressed from convex, dished out, to flat, the pressure increases. However, if the spring is depressed from flat to concaved, dished in, the spring tension will decrease. The diaphragm spring works or acts what is known as an over-center spring. When the diaphragm is flat, the spring tension is greatest. When the diaphragm is prior to or just past being flat, tension decreases proportionally. If we view the diaphragm spring from the top, we see that there is a hole in the center and part of the diaphragm is split to create multiple diaphragm levers. At the end of the split, a pivot pin or rivet is located. The pivot pin is used to hold the pivot ring in place. The pivot pin or ring creates an anchor location for the diaphragm spring to leverage from. If we once again view the diaphragm spring from the side, it will now look like two levers. As the diaphragm spring is compressed or pushed down at the center of the spring, you will notice the outer edges of the spring rise up. The rising and lowering of the outer spring edges via the retraction clip is what controls the movement of the pressure ring, also known as the pressure plate. Release levers are used on coil spring pressure plates to apply and retract the pressure ring via two pivot locations.
The coil spring is a push-release design. Pushing in on the release levers compresses the springs and pulls the pressure plate back. This releases the clutch and pulls the pressure plate away from the disc. Moving the release levers away from the flywheel engages the clutch or applies it.
Besides applicational differences, there are a few variations to the function of the diaphragm spring design. The push-release design requires a throwout bearing to push on the diaphragm springs to release the clutch. The pull-release design requires a throwout bearing to pull on the diaphragm spring to release the clutch. The self-adjusting pressure plate design automatically compensates for disc wear, and by doing so, clamping force and pedal effort stay constant throughout the life of the clutch. Due to wear, the friction material on the clutch disc becomes thinner. This causes the clutch disc and pressure ring to move closer to the flywheel. When this happens, the diaphragm spring becomes convexed or bowed out. This reduces the clamping force upon the disc and causes the driver to experience greater pedal effort. By being able to sense the diaphragm spring position and dynamically adjusting the length of the pivot point, the self-adjusting pressure plate restores the diaphragm spring location, therefore restoring clamping force and pedal effort. Zooming in on half the clutch, then switching to a Honda self-adjusting design, we will be able to see how the diaphragm spring changes position during friction disc wear. A sensor spring and adjustment ring are responsible for maintaining diaphragm spring position. As the disc wears, the pressure plate moves closer to the flywheel. The diaphragm spring position is adjusted via the sensor spring and the adjustment ring. The spring-loaded ramping mechanism is used to change the position of the adjustment ring. The center force clutch design operates on the principle that centrifugal force from the engine rotation reduces clamping force. Center force clutches incorporate centrifugal weights that are designed to maintain full clamping force regardless of engine speed.